Saxon Algebra 1/2. We're here today for lesson 117, which is our last lesson for the week of lessons due May 17th. Remember, we skipped 115. We did 116 last time. Now we're doing 117. Here's another place where I wrote it all down, right? We skipped 115, and then next week we're going to skip a couple too. So make sure that you don't forget and drive yourself crazy wondering why we're off in the lessons. Okay, I'm going to cross this off and teach you lesson 117. These are a couple nice, sturdy, one's technically geometry, but we're going to use, it's kind of algebraic feeling. They're just nice, sturdy, simple lessons with numbers and not a lot of words, and they're beautiful. Okay, if we are trying to find the square root of 4, we know that that is 2. We always write just positive 2, okay? This is called the principal square root. We use that to mean that we ignore negative 2. Now, it's true that the square root of 4 could be negative 2, right? Because negative 2 times negative 2 equals positive 4. But this radical sign says just take the main one. Just take the positive one, okay? And go ahead and ignore negative 2. Now, that's different than when we have this expression. Okay, this one, we don't ignore the negative root. Okay, here we do ignore the negative root. Here we don't ignore the negative root. So if we're going to solve this and figure out what number squared equals 4, we have to consider positive and negative 2. Okay, so when we take the square root of 4, we can simplify it, but when we have it in this form, it's kind of the same idea. It drives me a little crazy because it's like, why are they different? They're so much the same. I know it has to do with that pig house. Okay, so if you see a pig house, you can do, positive only. But when you see this, you have to consider positive and negative. The nifty thing is that we're saying positive and negative 2, but we can blur them into a simple little sign. We just connect the plus and the minus, and we can write it like that. So we can do things like this. Example 117.1, solve p squared equals 16. And you're going to see in a minute why we're reviewing this calculation. Okay, so we just take the square root of both sides, and we get p equals positive and negative 4. Does that make sense? Right? So sometimes the numbers come out even, but sometimes they don't. So let's look at that. P squared equals 42. Okay, 42 is not a perfect square, so what are we going to do? We don't know what that number is. It's not like 16 or 4 that has a perfectly cute little root. This is how we write the answer. P equals plus or minus square root of 42. Oh. So if we have an oddball number that doesn't come out perfect, you just say, it's the square root of 42. Whatever that is, we don't know. We know it's somewhere between 6 and 7, right? Because it's between 36 and 49. But I don't know what that number is, except that's a number. That's a way to express it. So this is a perfectly lovely answer. And that saves us a lot of drama in these kinds of problems that we're going to be doing. All right. Now we're ready for part B. Ready to feel smart? Part B is a topic called the Pythagorean Theorem. There. Okay. Once upon a time, there was a dude named Pythagoras, and he lived on a Greek island called Samos in the 6th century BC. So what's that, the 500s? All right, he was a mathematician. He was a Greek dude, and he lived in Greece. He also lived in Italy later in a town called Crotona. His name was Pythagoras. And he came up with this concept, this Pythagorean theorem named for him. This is a dude. And it is so simple. It's so elegant and perfect that it seems like no big deal that he discovered it, but it was a wildly sophisticated idea. This theorem only works for right triangles. That's important to know. Okay, there's a nice right triangle. Right triangles have three sides, just like any other triangle, but the three sides each have a specific name. This is called a leg, and this is called a leg, and this is called the hypotenuse. The legs come out from the right angle, and then the hypotenuse is opposite the right angle, right? It's opposite to that. I always think it looks like a piece of like a cardboard, or I always think of like an index card, something that would be fun to cut, and I imagine cutting along that line. I grew up during the days of Captain Kangaroo, you guys. I don't know if you've heard of that, but it was a morning television show for children, way more chill than Sesame Street, but the same kind of idea. Kind of like a Mr. Rogers, if you've ever seen that. And Captain Kangaroo was this dude who lived in a house called, what do you call it, the treasure house? And there were various puppets and a couple other actors that interacted with him. But one of the things he did that I loved, he told stories and planted gardens and did fun little wholesome things for kids. He also did art projects, and they would show him cutting construction paper with scissors, and they mic'd it in such a way that it made the most delicious cutting sound. And I used to live for that cutting sound. So I always imagine the sound of Captain Kangaroo's scissors as we're cutting the hypotenuse. Side note, sorry, I didn't warn you about that. Now, John shows a bunch of weird pictures in the book trying to explain the Pythagorean theorem for you. I don't want to show it to you because I think it's confusing. What I want you to know is that we label one of the legs A, the other leg B, and the hypotenuse as C. Okay? It doesn't matter which leg is A and which leg is B, as long as A and B are the legs and C is the hypotenuse. And then this is it. If you square this dimension and square the other leg and add them together, it will equal the hypotenuse squared. Like I said, that's so easy. You're like, big deal, who cares that he made that up? No, it's awesome. And we get to use it in all kinds of interesting and clever ways, and we're gonna start on that today. Here's a triangle. Now, we can reorient that, oh my gosh, the right triangle in lots of different ways. All that's important is that we check to make sure it's always a right triangle. 5, 4, 3. Oh no, A, I'm sorry. A. Oh, spoilers, hang on, my dog is raising a ruckus in the garage. I better go see what's happening. Okay, so I'll have to make this a part 2 video. I'll be right back.